kick this party off. Happy Tuesday. Happy Groundhog Day, everyone. I don't know what time I heard Punxsutawney Phil, the official one, like he did see his shadow, which kind of, I don't know how how one animal can judge the weather for an entire country, but here in Kansas City, he did not see a shadow this morning. So that means an early spring, I hope. But anyway, we've got a great lineup of content to go over today. As you can see up on the screen right now, we are still looking for speakers, always. We're very excited to have somebody, Corey, joining us today from NASB to talk about some TabPy stuff. Jay is going to talk about some table calcs, and I'm going to give a brief introduction and overview of Tableau's new data model, Noodles functions that was released earlier last summer. So I think the theme for today's meetup is the Twilight Zone. So these are 3 topics that we don't really get into that much. It might scare people a little bit. So we're hoping to ease some of those feelings a little bit. So, but without further ado, let's go ahead and kick it off with Jay talking about some table calcs.
Thank you, Sean. You guys see my screen? Is it good? Okay. All right, everybody. Thank you for coming in today. I'm going to do a presentation on table calcs from first to last. Table calcs can be pretty powerful, but also very confusing, at least for me. When I first started Tableau, I didn't have any formal training, and so it was just a new concept. So in this presentation, I'll cover everything you need to know in order to use table calculations effectively, from basic properties to some creative use cases that I will demo. A little bit about me. I'm the data visualization manager at Evolytics, a small consultancy here up in Parkville. Guess I'm working from home. So I've been in Tableau a little over 4 years now. I'm a certified desktop associate and also co-leader with Sean, Aaron, and Lucas of the KC Tug. And in my spare time, I like to rock climb and slackline and do yoga and lots of stuff outside. All right, so what are you going to learn today? So this is a presentation for Tableau developers. We're gonna cover what table calculations are. We're gonna look at some quick table calcs, which are probably the most commonly used type of table calculations. We'll get into some custom table calcs, and then I will demo 4 creative use cases for table calculations that you might not see every day. All right, so what are table calculations? Per the Tableau dictionary, table calculation is a transformation you apply to the values in a visualization. The calculations are a special type of calculated field that computes on the local data in Tableau, and they're calculated based on what is currently in the visualization, again, and do not consider any measures or dimensions that are filtered out. So the key thing here is they use data that is in your view. So if you need to do something with the data that you already have in your sheet, you can probably use a table calculation. And another thing is they can only be performed on a single measure. So you can't do a table calculation from one measure across to another measure. That's what really confused me when I first started. I thought it was like Excel, and I could just subtract this column from this column. Yeah, Kevin, let me know if anybody else having trouble. Aaron, okay. All right, so again, what are table calculations? What they need a measure. You have to have a measure you're going to perform them on. They need a scope or a partition, so that either be the table, the pane, the cell, or specific dimensions. That's going to be the domain of it, and then the direction. So how it's going to perform. Is it going to go down, across, or again, specific dimensions? So here's a screenshot of the menu for editing a table calculation in Tableau. You can see you have the calculation type, and then you can compute using, and that gives you the scope and the direction with some other options down there as well. So main thing is measure, and then scope, and then direction. So some commonly used ones that we see a lot, and these are all, Tableau has nicely put these in the quick table drop down for us are running sum or running total, difference from, percent difference from, moving average, percent of total, or rank. So if you need to do one of these, Tableau makes it super easy. You can basically do it with a couple clicks, and then you have your calculation that would have taken you a little bit of maybe a few calculated fields, some LODs to perform otherwise. All right, so let's get into some more examples. We're going to look at a difference calculation, and we have the setup we have is we have year of order date on our columns. We can see 2011 to 2014, and these screenshots are directly from Tableau's website, so they're pretty old. And then we have the quarter and then the month. So those are on our rows. The quarter is actually creating a partition for us. It's grouping by quarter and then showing each month within each quarter. So our difference calculation right here, the scope is the table. And so you can see it goes all the way to the end of the table, and then the direction is across. So across a row. So this is going to give us the difference in sales per year by month. We're going to subtract the sales of January 2012 from the sales of January 2011 to get a new value 2012. And then 2013 from 2012 to get a new value here, and so on. And we will not have any values in this first column because there's nothing before that column to subtract from, right? So we're getting values in the last three because we're going across. So difference in sales per year by month. Using the same table setup, but a different direction and the same scope, we're going to go down this time, which gives us a different calculation. It gives us difference in sales per month by year. So now we're subtracting February from January, March from February, all the way down the table. So now we don't have a value in our January row because our table is going down. So we get a difference in sales per month by year. Now looking at a different scope. So we're going down again, we're using a difference calculation, but our scope is now the pane. And this quarter field is setting our pane. It's giving us our pane, our grouping by. So we're gonna do difference in sales per month by year, restarting every quarter or every pane. So we only get two calculations here, and then it restarts. So we're not gonna get a value for April, July, October, or January, because we're subtracting May from April, August from July, and November from October. So it's restarting. This probably isn't the best use case, but this is what we have. We'll get into some better ones later. And if you haven't noticed, the table calculation gives us this, this little delta symbol on our measure to let us know that there's a table calculation being performed on it. So another commonly used method is to use specific dimensions. So here we're telling our table the scope and direction regardless of the orientation of the table. We're using the actual fields themselves. That way, if we move the fields around, it doesn't change the way the calculation is performed. It's still coming from going by the field itself, not where it is placed. So this is the same thing. We're doing difference. We're doing our scope and our direction, our specific dimensions. And to do this, we have to edit our table calculation. So we'll right click on it, hit edit table calculation, and we get this menu. Specific dimensions is selected. Notice that year is not selected. So this is going to give us our partition essentially. Month and quarter are, we're doing it at the level of deepest, which means the deepest level in our row, the way we're going down. So month is our deepest level here. And so it's going to do the calculation at the month level because month is the furthest right on our row. So this is going to give us the difference in sales at the deepest level, month, relative to the previous value, restarting every year, which is the unchecked dimension. So this is the exact same thing as the table down calculation. We're just doing it with specific dimensions and telling it. And we get some more options though. So this relative to previous is just doing the one above it, but we could set that to the first one or the last one, or maybe three above. That can be dynamic. So that's important when you want to do some complicated table calculations. You can change this relative to be fixed, always from January. So we can see the difference in sales from every month from January. And that might be a helpful insight. So now let's move on to some quick table calculations. So quick table calcs, I covered these earlier, and these can be accessed by right-clicking on a measure that's in your view, whether it's on the rows, shelves, or the marks card. We come down to quick table calculation, and we see the options that are available to us, and these are all commonly used. I use percent of total a lot, and percent difference too. Makes it really easy. You just check it, and then you might need to change the scope or change the direction depending on the way your table's oriented. But this is how you get to them. So let's look at some examples of these. So this is a running total. The scope is the table and the direction is down. So here we can see the example of the actual sales for each month. I put that as a header, as a discrete header, so we can still see it. And then notice on our text label, I've got the table calculation for running sum going down. So we can see the first month, yep, 14,000. Second month is 14 plus 4, yep, plus 55. And so we can see that easily what the result's going to be. And if you didn't know, you can just type in placeholder text labels in your columns and rows if you just want to make faux headers that are nice. So here's another running total, and this is the exact same calculation. It's just going across because our table structure is different. The previous one had month on rows and our label. This one has month on columns. So instead of going down, we're just going to go across. Same exact calculation. And now I have my sales on rows, and it's going to be a line going up. We get the same resultant number. This is usually how you probably visualize a running total. Percent difference. Here's an example for percent difference. Really easy to make. Just going to give you the difference between this month and the one prior to it. We can do percent of total. I use this one a lot. As I said, it gives you how much that makes up over the total. So it's actually using a total function as a denominator and then using the sum of sales as the numerator. And so you could do the exact same thing with a level of detail. It's just a lot faster with a table calculation to do this. Here's one for rank. So again, this is assigning a rank function to your sales, how relative to the total sales. I've used this sometimes for coloring. If my scale is way too big, I'll use rank to kind of differentiate the colors between the values. And here's percentile. So very similar to percent of total and rank put together. Last one we're going to look at is moving average. So this is, I've charted the sales in gray and the moving average in blue. And here we get some more options. We get to look at the previous two or include the next. We can actually, alter this by editing the table calculation to tell us the moving average over a scope that we want. And you get to this again by right-clicking, clicking Edit Table Calculation. So what is Tableau doing when you make a quick table calculation? Well, you can actually see it. If you go and right-click on your measure and click Edit in Shelf, it'll give you the syntax that Tableau is creating to get this table calculation to work. And we can see that the running average is actually a window average function using the sum of sales and using -2 and 0. So that's the offsets. So again, right click, click Edit in Shelf, and you're able to see the syntax. Something else you can do with table calculations, quick table calculations, is you can actually drag them from your view into your data pane, and it'll create a calculated field for you that captures that table calculation, and then you can name it. So notice in this GIF, I'll drag it down, I'll rename it moving average sales, and then that calculation actually is renamed up in my sheet to moving average sales. So you can capture that, and it's easy to save for later. You can then adjust the syntax inside the calculated field. You won't have the option to edit that calculated field anymore in your paint, in your view, but you can actually edit the calculation itself. So this is really handy. Another thing that's good to use is the calculation helper. So here, if you want to know exactly what this table calculation is doing, you can bring it down in here. You can, into your calculated field, you can open up the little calculation helper to the right and then click on it and see what it is. So window average sum, the example is profit, but I'm using sales. So it's the average sum of sales from the two previous rows to the current row. So it's taking the average of those two and then plotting that point. And so you can see with table calculations, it's an aggregate inside of an aggregate, right? So we're actually using the sum of sales and we're taking the average of the sum. So you're double aggregating. You're getting a value and then you're getting another value from that. All right, so that's a good segue into custom table calcs. So that's creating your table calculations in the calculated field editor. So these are all of the table calculation functions that Tableau has. And we have a few that are row like specific. So first, index, last, and lookup. Rank, we covered that. There's actually a few different kinds of ranks. A lot of dense, modified, percentile, and unique, depending on how you want the rank to actually calculate. We have running average, running sum, count, max, and min. We looked at running sum earlier. We have some script ones that I don't really know what they are. Size and total. Size, again, is like the size of how many rows or columns you have. Total is kind of just like an aggregate gives you the total, essentially, of your sum. Then we have a bunch of window functions. So we just saw window average as our running average. So it's the average of what you have in your window. So this is all of these functions will just give you another value after you've aggregated all the values that you're displaying. So looking at rank, we looked at this one earlier. So this is what the syntax actually looks like. We can put sum of sales inside the rank function and then rank them. You could actually put profit in here and show it with sales if you wanted to rank profit and look at the sales together. So you can independently, chart the rank based upon a different measure if you want. Index is going to give us the row number just straight down. This is pretty handy. We'll show a good use case for this later. And then first and last functions are kind of like index. They're just giving you the distance away from either the first row or the last row. First is going to get negative as it gets further away. And then last is going to go from a positive value to 0 as you approach the end of your table. And we'll show another good use case for this as well. So window average, I just want to show this one. This is what window average looks like. Sum of sales. So this looks very similar to a level of detail, right? When you need to calculate a level of detail, you want to get one value. You can easily do that with a window average. And then this is going to respond to any filters or any other dimensions that you put in your view, and the window average will change. So this is really handy. And we'll show a good use case for this in a second as well. So this is taking the sum of sales and then getting the average of each month. So it's aggregating it, the average, the sum of all these, and then averaging it, and then you get the value. All right, let's move on to the good part, creative use cases for table calcs. So here's a business question. So what's an easy way to show only the last completed month dynamically, right? So I run into this a lot where we'll have, data, we'll do like a week over week or last completed period, right? And I'm using a table calculation to get that percent difference, which is what this is. So in here, we have a table calculation that's showing the percent difference in sales by month. And so let's pretend that I don't have a year filter on there and it's January right now, but as soon as January ends, we're gonna wanna see the difference in sales from January to December, right? But I only wanna see that one cell. I don't wanna see everything else. I just wanna see the most recently completed period. So I could write some calculations to do that for me, if statements, if the current period equals this period and whatnot, or I can use the last function. So the last function is, again, it's going to get smaller and end at 0 at the end of your table. So if we create the last function and then put it on here on our text label, we can see that there are 12 columns. It starts at 11 and goes to 0. So we can actually use that in a filter, put last on our filter, and then go at most 0. And that will give us just the last column. And it'll always show us only the last column in our view. So then it doesn't matter. We don't have to write any complicated, date filters to figure that out for us. So I'm going to switch over to Tableau and show this to you guys. Let's make this a little bit bigger. All right, so here's what we got. We have sum of sales. I've just got it filtered to a year. I have my month of order date discrete up here on my rows or my columns. So I'm going to do one table calc first to get my percent difference, because I want to know the difference in the percent difference in sales by month. So I can do that. And since there's only one direction here, Tableau just defaults table across, right? There's no table down, there's no more rows to go down. And so it's giving me table across. I don't need to change that. Order date is actually going to be the exact same thing because I have order date on my columns. So those two are going to be the same in this instance. And if I want to use color for that, I can just hold Command or Control on a PC, drag it to color, and now I'm coloring by the same table calculation that I'm doing in my text. I'm actually going to change this to a square and then give it a white border. There we go. So now I can see a difference in sales. I can see I have a really good month here. I have some kind of bad months in here. But I really only care about this last month, right? So I create this table calculation. All you got to do is go put last in a calculated field. I call it last. Pretty simple. Hit OK. And then we can drag that out on our label and see what value it gives us. Whenever I'm working with these, when I first started, I wanted to know what it's doing. And so I drag it out so I could see it and say, OK, I can use this. All I want is this last one. And so I'm just going to take it, put it on my filters. I get range, at least, most, and special. And I just want 0, right? So you could also do this as a discrete value and just select 0 instead of any others, but this is what it gives me first. So hit 0. There we go. I think that's standard. That's what I got. So pretty simple. Use this in a lot of my visualizations for period over period change. Okay. All right, so another one we got. What's an easy way to show percent of sales for just the furniture category? So let's say I have a distribution and I just want to show one at a time. Maybe I want these in like different sheets just so I can like align them perfectly, or I don't want my data to disappear if one category doesn't exist in a certain time frame. So an easy way to do this, first I'm just going to use the percent total table calculation. So I can do that. So I get the percent total. And then I can use the hide feature. So this, I wasn't really taught this. I actually got into some workbooks. I think one of them was actually Lindsay Poulter's, and she had stuff hidden all over the place. I never encountered it before, and I didn't know what was going on. And it took me a while, and I finally figured it out. And I was like, oh, that's genius. You can use table calculations and the hide feature to preserve your values, right? Because if I wanted to filter for furniture, then I couldn't use a table calculation anymore because now my data is no longer in the view. But if I can use the hide, it just hides it from view. The table calculation still computes correctly, and I have my value. So let's go through this one. So I have my category on my columns. I have my sum of sales on my text. I'm going to do a percent total. So I'm going to do a right click or click the caret, click table calculation, come down and select percent of total. Again, I only have one direction here because there's only one dimension out on my view. So it goes table across for me. And the next step is I only want furniture, right? So I'm going to click on office supplies and hold shift and click on technology. And then I'm going to right click and click hide. And there we go. Disappears. I have just the value I need. This is going to respond to any filters as well that I put on here. It's going to be really dynamic. It's going to be nice. And if I ever want to see that data again, I can either click on the header here, or I can click in here as well and click show hidden data. And there we go. Then it reappears and I can see it again. So really handy, nice combination of percent total and hide. I use that all the time as well. All right, use case number 3. How can we easily categorize and visualize subcategories that have above average and below average sales? So I've got this chart already. I have my sum of sales on columns and my subcategory on rows. And I've just got it charted. I've got just all the same color, no delineation right now. So since I'm looking for above average and below average sales, that value should be in my view already, right? I'm just looking at this view. So that means I can use a window average function. So I can actually write a calculation that says if the sum of sales is greater than the window average of the sum of sales, so everything, the average of everything, then I'm going to return a string of above. Else if the sum of sales is below the average, then I'm going to return below. And then I put an else in here for equal to on the off chance that it's the same. So I'm going to use a string calculation with this window average to get these values. And then with that, I can put it on color to get my color to change. And then I can also put it on my rows to get the grouping, just so I can see that a little bit more clear. So I used the window average in a calculation to return a string and was able to color and then group by on my visualization. So again, this is going to respond to filters. It's going to be really nice. So to see what that looks like, here's my starting viz. All I need to do is create one calculation. Here it is. So again, sum of sales, so that's going to be the row. That's going to give me the row value is greater than the window average of the sum of sales. So it's going to take the sum of everything of each one of these values, get the average of it, and then that's what's going to return here. So that's going to give me my above. I'm going to do the same thing for below and then equal to. Take that, put it on my color. I already had this sorted, which was nice. So I can see where that line is, right? Binders is above, accessories is below. And I can also just drag it out here and get a nice grouping for above and below. I could use this as a filter, right? I could say, hey, I just want to see stuff that's above, or I just want to see stuff that's below. A lot of different ways you can use that. All right, last one here. This one's a little complicated. How can we visualize subcategory profits over time normalized to a starting date? So let's say that, I didn't start selling a product maybe a year until after my business started, but I still want to look at every product or every subcategory from the same date to see how my profits changed over time from a normalized date. So essentially what I want is a chart that looks like this, right? So these are all my subcategories. I've got a normalized date here. They all start at one point, and then you can see some of them end, right? Which means either I stopped selling them or I started selling them late, one of the two, because we're normalizing everything to like the count of months that I've been open. So some of these do stop short, but some of them go all the way. So we can see which products over time have been the most profitable and which ones have been the least profitable. Some of them have oscillated. So to do this, takes a few, we're going to use specific dimensions for this one. So what we're going to do is we're going to use subcategory on color, right? Our level of detail is going to be at the subcategory level. That's what we're going to color by. And then we're going to chart it by the month of ship date, but we can't use the month because we have different months, right? So we're just going to use that to compute across, but we're going to use our index function as basically our time series, as our relative position in time. And we're going to do sum of profit, our running total over time. So month of ship date's in my view, so I can use that as my specific dimensions to calculate across. And this is what I'm going to end up with. And you can see at the bottom here that I have my numbers on my x-axis are not months, they're integers because I'm using the index. So let's go ahead and build this one. So I actually got this one off, I think I got this one off Tableau blog. They built it kind of a long way, I guess you would say. But if you think about it, what I want to do is I want subcategory on color, right? So I can put that there because I know I'm going to chart my subcategories. And then my month of order date, I'm going to hold option. I'm going to drag that on my detail. And I want it to be continuous month, right? Because I want over time. I want successive months on a scale. So month of order date. I'm going to take my profit, put that on my columns. And then I'm going to do a quick table calculation on that of running total, right? And here's where I need to compute using subcategory. So we can come in to edit specific dimensions, month of order date. So I want to compute it, my running total on the month of order date. That's what I want. I don't have a time in the view yet. If I take index, put it out here, I'm going to make it discrete. And I'm going to compute that using order date as well. Oh, I think I switched these. There we go. Yeah. And then just change this to a line, right? I want to see a line chart. So that's what I get. These are both computing by the month of order date, which has to be on here somehow, right? It has to be in my view. And so I put it in the level of detail. So those are the computing by, and get my index starting at 0, going to 48. Yep. And then using subcategory. So now I've normalized my dates using index, and you can still see the month inside your tooltip. You could put on your labels. You could probably actually put, yeah, I would just use tooltips or something like that. But now I've normalized it, and now I can see everything. So we use this for like A/B testing at Analytics. If we start multiple tests throughout the year, and we want to see them, how they all compare at the same time, then this is what we would use to kind of see how people are performing against certain tests. All right, that's all I got. Thank you. You guys have any questions on table calcs?
That was really great, Jay. I haven't seen any questions come in, but if you guys have any questions, be sure to use the Q&A feature or use the chat feature, and we will let we'll let Jay kind of take care of that as we're doing it. That was great, Jay. Thanks a lot.
Yep. Thank you.
You bet. So real quick, just to kind of continue on what he was talking about, I did want to point out, if you want to practice your table calc game with without a necessarily a use case in your business case right now, that is a great way to practice your skills is, of course, Workout Wednesday. So definitely check out Workout Wednesday if you want to grow your skills in technical Tableau building. And one of the really cool things is if you land, so here's the website, workout-wednesday.com. If you go over here on the top to challenge insights, we have aggregated all of the challenges back to 2017. And what's really cool about this is we have a content filter. So if you wanted to, you could go in here and you can say, okay, I want to show me all the challenges that have to do with table calculations. And you can do that. And then what you can do is you can just, you can click on this and it will take you straight to a challenge where you can practice using table calcs. So we give you the final viz, we give you the requirements, we give you the data, and you get to go figure it out. So this is a great way to practice your doing some of what Jay just showed, using some of the quick table calcs, using some of the making sure you get your syntax right, and using creative table calcs to do some of that really cool stuff. So definitely check that out if you're interested in that. Cool. All right, we are going to just keep on rolling here. Next up, we've got Corey. Corey's in the community. He works at NASB. I'll let him do his official introduction, but really excited for this one. He is going to talk about TabPy and implementing TabPy in Tableau. So Corey, take it away.
Yep. Thank you, Sean. So as he said, I work at NASB. I'm a data scientist there. We're a mostly regional bank, but we do a lot of residential lending, home mortgages and such across the country. So that's the primary business area I work in. And so I've been using Tableau off and on for about probably 4 years or so now. It's really, in my role, it's my tool I use to deliver usually the data product, whatever I'm producing, to the business user. And so I usually am finding workarounds to do exactly what I want within Tableau. And so that's kind of how I stumbled on TabPy. I do most of my work within Python. That would be my preference if I had to choose one. And so when I stumbled on a blog post a year or so ago about this interface between Tableau and Python, I've started leveraging it as much as I can. So I reached out to the organizers and said, hey, do you think this would be of interest? And so that's why I'm here. I don't want to go too deep into the Python stuff. If there's an appetite for that, I'd be happy to have a further conversation around that, how to set it up, how to do some of those things. We can take that offline or whatever. But I at least want to give you an idea of how to set it up so that if you're Python familiar or you have somebody on your team who's Python savvy, you can work through that process and then give you just a little taste of kind of what you can do with that in Tableau. So I won't be quite as thorough, let's say, quite as in depth as Jay was, but it's more of just kind of whet the appetite here. So obviously the first thing we need is Python. So however you get your Python distribution, there's plenty of packages out there that bundle all these things together. I've put some kind of pseudo code here. If you have a working Python environment, you should be able to go and install TabPy today. It's distributed with most of those distributions. And I typically use a virtual environment, so I put all that here. The interesting thing is you can actually run this. It's a server. Essentially, it's offering up this web API. I believe it's built on a Flask distribution. So it's offering up this web API and an interface into Python so that you can basically pass these scripts back and forth to this Python server. So that server can be running locally on your machine. Typically, that's a good use case if you're testing things. But we actually have it in a development environment at NASB running where we can connect our TabPy, our Tableau server instances and workbooks running there to this dev server that's running TabPy. So you can do that across different machines. So the first thing, once you get the Python side of things hooked up, and I know that was brief, but we can discuss more if you're interested. You have to kind of monkey around in Tableau a little bit to get it set up here to point to this server. And there's no clear way on where to do this. So you actually go up here to help, which is interesting. Settings and performance. And then there's this analytics extension connection. And there's a similar setting on the server side. If you have a Tableau server that you're using, it's kind of buried within one of these menus to where you set up an analytics extension. So you click on that and then you point it to the server. In this case, it's running here. I can show you, just kind of demonstrate. It's running here in this terminal shell, and it'll spit out output as I pass Tableau functions to it. And then there's also an R version of this in some sort. I've never worked with that, but if you're more familiar with R, I think you can do a similar thing with passing R scripts back and forth. So look into that. Test my connection here. It says it's successfully connected, and that's it. So now we've got the ability to run Python scripts here within Tableau. Now there's a few things we have to kind of sort out before we can actually do it. It's a good thing that Jay actually went here and presented on table calculations, because that's what these ultimately are. Those scripts that he mentioned that he didn't know what they were, those are the tools we were actually going to use to pass things back and forth to this TabPy server. So it's a great follow on to that. Although we did not plan that, it worked out great. So because of that, because they are table calcs, we can only pass aggregates to these calculations. So you can get around that a little bit by using the attribute function, but it's expecting you to pass some sort of aggregated field in the same way that you would a table calculation. So that's one thing to keep in mind. And then there's a few nuances here in terms of how that interface interacts with one another. It essentially has to be something that is JSON serializable. It has to be an array, but it can't be a special Pythonized array. So like a NumPy array or something like that, you have to turn it into just a standard list object before you can return it back to Tableau. Easy enough to get around, but something to be aware of. And then finally, we have to select the return type. So if you're passing back and forth strings, if you're passing reals or integers, you have to tell Tableau what it's expecting, so that it can, define that Tableau variable correctly based on that input. So I thought I would just work through a couple, kind of toy examples here that you wouldn't necessarily need Python for, but just to kind of get you an idea for the interface. And then I built kind of a toy example of a prototype of what we actually have running at NASB that we're using it in one way, to demonstrate how it's coming useful to us. So as with any good, programming start, we're just going to define a hello world example here. So if I go over here to I've conveniently prefixed all of my Tableau functions here with TabPy so I can find them easier. So again, that script table calc is what we're going to use. In this case, I'm returning a string, and it doesn't even look like I'm really using Python in this example, right? I'm calling a script string, and I'm returning just this hello from Python string. But if we watch, as let me change, if the variable doesn't change, it's not going to recalculate it. But if I click OK, it's passed that back and forth to Python. And if we look at my output here, you see that it has returned, right, this string. So it communicated with that local Python server. It calculated the fact that it needed to return that string. So we're all set up and ready to go. Just kind of another test. So the first thing I thought to do is, and again, I'm glad Jay presented before me, because table calcs are something that I've struggled with personally, right? I never understand how exactly Tableau is trying to do these calculations, but I could write the same thing in Python, right? I know how to interact in that environment. So the first thing I thought to do is, what if I wanted to take my sales here, and instead of have raw values, I wanted to normalize them. So I wanted a normal 0-1 distribution instead of the however scaled the distribution of sales here is. So you could do that with a table calc in Tableau. You could subtract off the mean, divide by the standard deviation. You can do the window functions, and you can get the exact same result. Again, I work in Python, so it's easier for me to think of it this way. I'm going to pass sum of sales in the same way you would to a regular table calculation. Pass that over to Python. I'm going to use NumPy here, so I can import any Python packages I want: SciPy, NumPy, sklearn, all of those packages that are available to you. As long as they're installed in your Python environment, they'll work here, as long as they're installed on that server Python environment. So I'm going to use NumPy. I'm going to normalize this sum of sales. So a couple of things to point out. Each variable that I pass through these scripts, I can pass multiple. So I could also do sum of profit here, for example. Each variable you pass is indexed with this underscore argument 1, 2, 3, 4, so on, as many variables as you pass. Don't be confused if you're a Python person. Tableau starts indexing from 1, so you have to reconcile your 0 indexing and 1 indexing here. But underscore arg1 in this case refers to sum of sales. If I had an underscore arg2, it would refer to the sum of profit. And I've got another example here that's got multiple arguments, so we'll see that as well. So what this is going to do then is take my sum of sales, subtract off the mean of that sum of sales, and then divide by the standard deviation, giving me a normalized array. Now, again, all of these things are being passed as arrays. So this is giving me, an array of elements indexed by my order ID. The normalized object is a NumPy array. In this case, I could, test that. I could return the type, and we could look at that. But I need to convert it again to those JSON type objects. So I'm just going to convert this to a list, and that will. I didn't actually pull it over. So when I pull this over, it's actually going to. Let me actually do it this way. It's going to run that calculation again. You see here, it's called that calculation and return the result. And it's giving me the normalized values back. So we could get, way fancier with that calculation. If you've got some more advanced analytics you need to run, it's the same procedure. If you're developing, say, a predictive model or something that takes, a many steps, many iterations. Maybe your test and train data are separated. They don't all live in your Tableau environment. You can actually build these functions in your Python environment and then register them, deploy them to this TabPy server, and just call them from within Tableau. So I've done that with this function. I've somewhere. So I have defined this function within Python, and I'm not going to go redo it here. I've kind of got the pseudo code. I think this is workable code here, actually, if you copy and paste this into Python, where I've built that same function. So I'm going to pull in some TabPy tools that I need so I can connect to this same server from Python. I'm going to define this normalize function, which was the same function we just wrote in Tableau, but now I'm defining it as a Python function. And I'm going to deploy that to my TabPy server here. So what this does is it basically registers that function on the TabPy server and says, hey, I had this function called normalize. You can now call that from any connection to TabPy server. Doesn't need to know what went in to build it. It just needs to know how to calculate and return. So if you've built a advanced predictive model, as long as the coefficients are there, you can register that model and then call it from a Tableau instance with different data. Okay. The syntax for actually interacting with TabPy is a little funny, if you ask me, but you're able to query essentially any one of these deployed functions. So that's their mechanism. It's TabPy query, and then I've got to give the name of the function and pass the arguments. I'm not given any information on how many arguments, what type of arguments. I have to know that, assuming I built the function and deployed it myself, I would have that information. So this arg1 here is going to get passed to the first arg of my Python function, and then it returns its own dictionary of various things, a response and some other characteristics about the function and the data that was passed. If I just want the actual result of this normalized calculation, I select response. And again, that response, because it's the normalized function, is a real value, right? I'm returning real values. So this should, when I do it, as long as my function is set up correctly, and I did that again, calculate the exact same thing. But now it's called my, it is called my TabPy function this time instead of the calculation that I defined in text there. So again, this is a rather simple example, but you can think about doing much more complicated functions where you're pulling data in from different sources in a Python environment and just calling those from Tableau to deliver them. Okay, so that's one way in which we've actually used it. We've got some predictive models that are able to operate this way on new data as it comes in. And it's a nice, clean way to deliver those results to the end business user. The other thing that I like to leverage is the ability to actually read and write some data from within Tableau. So I've got a simple little example here just to kind of give you an idea of what's behind the scenes. We can actually rely on the same type of connections that Tableau has within Python to read and write from SQL databases, for example. So I can connect an ODBC connector to some SQL server I've got running, and I can send it a query and read some data. So I have set up this comments table here, and I will show you what the data looks like, just so you get an idea of what we're dealing with. So I set up this table thinking, hey, I want to have a tool where the end user, my business user, can go in and add a comment to the orders list, right? Maybe they're working on this together. They're using Tableau here to communicate about the status of orders. Probably not a production system, right? But this would be good in a test environment or prototyping out eventual engineered applications. So I've got an order ID, a comment string, and then some modification data to know who modified it when. So I've set up that table in my SQL server separately. And here I just want to read some data from it, but I want to filter it to, specific order. So I've got this filter here. right? I can select the order, give me all of the comments associated with those orders. In this case, it just returns kind of this messy looking string. Again, it just, serializes the whole thing. So it's one giant string of all the details from that query. But the use case for this is actually to build something like that, order comment system that I kind of described there. And this is similar to something we actually have being used in our dev environment today. That's become very useful for our operations teams. So if I've got a list of orders here, and let's say, I want to add a comment here on Jasper's order, I've kind of tricked Tableau into when it calls these Python scripts. So I've got a script set up to read the data from the server, like we just looked at. And then I've got a script that's set up to write the data to that SQL database. So something that you typically wouldn't be able to do easily within a Tableau dashboard. So I'll show you the functionality, and then I'll go show you kind of how the TabPy actually works. And it takes a little while to run. One, it's my local machine. Two, it's running this calculation on all of the orders every time I click a button. Again, not a production system, but so if I want to add a comment here to Jasper, I can say, Jasper order is sent. Click stop editing, and when I click stop editing, it's actually going to call the TabPy script to write that to the database. And again, it'll take a few seconds to recalculate everything, and then we should see it pop up here in my list. Maybe. There you go. So if you notice, these buttons, show and hide, these are separate worksheets that are, again, tied to those calculations. I've set up a parameter here that the dashboard actions actually changes based on when you select one of these buttons. This note editable field will flip from true to false, so we know whether or not we need to execute those scripts. So again, I'll run it one more time just to show you. This is going to flip to true, meaning whatever we're entering now in this parameter field is a note that we actually want to send to the Tableau TabPy instance. So let me actually look at insert note. So I'm returning a string. I'm not actually using this string anywhere. It's just a, insert successful or there was no insert. But what I'm actually doing is I'm passing, again, an order ID. So I have that information to write to my table. The username of the current user, right? So if I'm on a server instance, it's going to pull that user information from there. That's what I'm using for the modification information to put a marker on who modified that note. I'm also pulling the mod date time from the SQL query itself. The string, this note string parameter with a note that I actually want to save for that order. And then I'm passing this note editable field so that I'm controlling when this portion of Python gets executed. So if that variable is true, I'm passing the Boolean to Python, it's going to evaluate it. And if it's true, it's making a connection to my database and it's inserting, right, whatever those comment strings are. I actually can highlight the whole query here, into that comments table. So I'm actually writing to the SQL database here. arg1 was my order ID, current timestamp, user, and then arg3 was my comment string, my note string here. So again, this is something that I didn't know how else to do in Tableau, but we wanted this functionality there. So TabPy actually gives me a mechanism now to do that. It's not advanced analytics at all. It's literally just read and write, but it's another interesting use case for TabPy. So that's really all I had prepared. I'm happy to answer any questions, whether it's deeper on the Python side or how to work with it in Tableau.
Awesome. Thanks so much, Corey. That was great. One question did come up, and and I think you kind of elaborated on it, but why do you need Python and R when Tableau has built-in scripts that can aggregate and create visualizations for you? Are there any other advantages to doing that?
Yep, absolutely. So again, the examples I had here, you know, the normalized data, you absolutely did not need to use TabPy. But if you're trying to execute those predictive models, or again, the writing more so to the database, I don't know of another way to do that within Tableau. Now you can make the argument whether or not Tableau is a good vehicle for doing that. That's a separate discussion, right? But if you had the desire to do it, that's really the only mechanism I know. I think its intent, you know, from everything I've seen from Tableau and the developers, was to open up that ability to run those more advanced analytics, right? To build predictive models and then evaluate them essentially on your Tableau data. And there's some great, you know, blog posts and other tutorials on more in depth on that side out there as well. I really just wanted to give a smattering of ideas here.
Yeah, no, this is great. Yeah, I think definitely when you talk about writing data, I think you mentioned having it. Is it necessarily the best use? Is Tableau the best use case? And there's certainly arguments being made, but one in favor is it keeps you in the workflow, right? I mean, if you're in Tableau, you're analyzing data, and you want to like, I need to say something about this. They don't have to go to another screen. They don't have to do anything else. It's all just right there. So
right. Exactly. And just a little bit more insight on that. Our use case is it's essentially a work list that multiple people are looking at. And it's not, you know, mission critical data that they're entering here. It's really notes to each other to say, hey, I've sent the whatever requirement on this, or this still needs to be done, or this one can't be worked because of such and such, right? So it's more of that communication mechanism for the team.
Yeah, for
So,
sure.
yeah, absolutely.
Cool. All right. Well, how can people get a hold of you if they want to?
You guys have my email. Feel free to pass that out. I can make this workbook available if anybody's interested. It won't function unless you install, you know, the TabPy functionality on the back end, but it's all in a Git repository I can publish and share with whoever is interested, and we can figure out how to do that if we need to.
Cool. Excellent. Yeah, I'll do that in my recap email that I send. I'll have Corey's email in there in case you want to reach out to him separately. So thank you again, Corey. We really appreciate you taking the time and volunteering to talk. And thanks for that. We've got a $50 Tableau gift store gift card coming your way, so you can get some Tableau swag. So be on the lookout for that. So thanks again. Appreciate it.
Thank you. Yep. Thanks for having me.
You bet. Cool. All right. Let's get going here with our final presentation. And we are going to be talking about data models in Tableau. So let's get that out of the way here. There we go. All right. So data models. Data models were introduced in Tableau 2020.2. And for new users of Tableau, if you've been using Tableau since then, this is not going to be anything new. And it's probably going to be the best thing you've ever heard, because it's the only thing you've ever learned. But if you're an old fogey like me, this is going to be kind of a paradigm shift, right? Because we're no longer joining tables together. You still can, but the default is you're going to be relating tables together. You're no longer joining them together. So we're going to talk about that. We're going to talk about all of the new semantics that we're going to talk about. So we've got a physical layer, and then on top of that we have the logical layer. So we're going to talk about some of those things. We're going to talk about the similarities and differences between data sources and data models. So in the old world, you were creating data sources, but now you'll be creating data models. And we'll talk about why that is, why we're talking about those in just a little bit. And then lastly, we're going to talk about the difference between a join and a relationship. We're going to get to know the new UI, what it looks like. And then lastly, we're going to jump into Tableau, and we're actually going to build out a data model, and then answer some very different questions and what you know, what are some differences? How is this going to change your normal workflow from what you've done before? So again, if you're new to Tableau, this is going to be a refresher, or it's just, you might pick up a few things, but if you've been using Tableau for a while, this is going to be new. It is not scary. I do want to preface that. Please don't be scared. It is just fine. And it's actually pretty exciting because, so like I said, in the old world, we had to do joins, right? And everybody knows them, everybody loves them. Left joins, right joins, Cartesian joins, outer joins, left, right, center, all of that stuff, right? Those are not going anywhere. They are still there. You can still get to them. But we also know that joins come with choices, and choices come with you know, things that you might have to consider. One of the things is, by doing some types of joins, you might be restricting the data in certain ways, right? So, which is something that you might need to keep an eye on. And by doing that, you might have different data sources for different questions. And so that may result in duplicative data sources used to answer different questions. On the flip side of that, what you could do is just be like, I'm just gonna left join everything and bring everything in, and then I'm gonna have to deal with data duplication, right? So usually you're gonna have to do some pretty heavy level of detail calculations to reduce that duplication of data. And we all know that the more level of details you add to your workbook, the bigger slug on performance those are going to be. So this is where relationships are going to be come in really handy. So what are some of the benefits of data models and relationships? Well, there's less upfront data prep. You just bring in your tables. You bring them in as you want, and as they are, you relate those two together on one or more fields, and then you just start building. So, which is going to be really nice. Because of that, you're going to have more use cases for each data source, right? So now in this new world, think of data source as a database table or that logical layer. And, you know, because we're not going to be restricting data in any way, Tableau is actually, this is where kind of the nuance thing. So in the old world, right? So Tableau, you created a data source, you joined everything together, and then you brought it into Tableau, and then Tableau created separate queries based on the worksheet, right? Now, in the new world, Tableau creates a separate query for each detail mark in your worksheet, and then joins that together based on the dimension headers, right? So basically, what does that mean? It means that you're going to dynamically change the query that's sent to the database based on which fields, dimensions, and measures that you bring out and where you put them, which is going to be, again, this is where you kind of have to start thinking differently about the way that you do things. So, but one of the other great things is you're going to have greater trust in your results because you're not doing a lot of that pre-processing of your data, because you don't have to do deduplication with LODs. It's just the number. It just is. You're going to have greater trust in the results that you get. Like I said, joins are not going anywhere, but we do have to kind of start thinking in different layers. So we have the physical layer, and that's the joins. That's where, think of physical, meaning I am explicitly telling Tableau how to join these two tables together. Every single time I bring out something from this table, I want it to join to this table on a right join or a left join or an inner join on this dimension. And it will do that every single time. And then there's the logical layer. The logical layer is where you have these noodles. You don't have the Venn diagrams that you're used to seeing. They're just connections. And then another way to kind of view this is like this, and I think this does a much better job. So we've got the physical layer on the bottom. Physical layers can be either single tables, or they can be multiple tables, either joined or unioned or a combination of both. And then up there you have the logical layers, which relates those two physical tables. So again, and then all of that is called a data model. So just again, new semantics, new kind of learning, but again, it's nothing to be afraid of. I've been using it not in production, but I've been using it in some of my Tableau public stuff that I've done, and it just works, which is really nice. So, so this is, in a minute, we're going to jump over into Tableau, and this is the data source that this is the data model that we're going to build, and I'm going to show you how to do that. Again, this is a very nice data source that was created by Tableau for the sake of demonstrating data models. So you can go get this data source and follow along, or do this afterwards and practice. It's called Bookstore, and you can find it on Tableau's help files. So this is what we're going to build. So let's do some Tableau. All right. So the first thing I need to do is obviously connect to the data. So it is an Excel file. I'm going to go here and Bookshop. I'm going to open this. To this point, nothing has changed, right? We shouldn't be scared. All right, so now we're here. Now, again, if we look back at our, there we go. Nope. Whoa, here we go. One more. There we go. So the first thing we need to do is we're going to build this physical layer right here. And so that's going to be, we're going to bring out our book table, and we're going to bring it out on into our canvas, just like that. Now, the next thing that I need to bring is my info table out, and I could bring that out, and what's going to happen is you see that we get these noodles, right? You immediately get these noodles. It's not what I want. I want the Venn diagrams, because that is a physical layer. So you right click on your table, or click that drop down menu, and you click open. Now we're into the physical layer. We know that we're in the physical layer because we have this border right here. And we can see up at the top that book is made of one table. And then it's got some icons here that's going to tell you exactly what's going on. So now I can bring my info out, bring it up just like there. And now I've got, here I have, this is what I'm used to. I'm very comfortable with this. I'm having a little bit, I can breathe really, I can breathe freely here. I do need to create a join calculation to get these two together. It's book ID 1 concatenated with book ID 2, and we can interjoin that on book ID from our book table. I'm done with that join. I can do that. And now you can see I've got my table just like I want it. Now I'm going to click out of the physical layer to go back to the logical layer. And now I can just start bringing out my other, tables here. So we've got award. I'll just click on, award. I can double click, that will bring it out, or I can bring it out. Now, again, Tableau's smartly going to look for common fields between my tables. It's automatically going to do that. If I wanted to relate on more, I could, but we're good with this. We've got performance options down here. We're not going to look at that today, but for each relationship, you will have the ability to fix the cardinality as well as the referential integrity between both of the within each relationship. You'll be able to set that manually. But by default, it will be a many to many and some records match. And basically what that means is all records from both tables will always be retained. You can always get them back. So I'm just going to go ahead and get the rest of my stuff out here. So we've got checkouts. We've got author. We've got edition. Yep. Again, this is nothing new, right? This is everything that we've done before. We'll bring publisher out. And as you can see, as I bring publisher out, it automatically found that I don't have a matching table on book, and it's automatically going to look for, it's automatically going to join on the edition table, relate on the edition table, not join, relate. Even I'm still working on the terminology here. So publisher, we'll do ratings, which again is going to be down there. And then got one more, which is series. And then the last thing that we're going to build is the, we're going to bring sales out here. And it's going to join on edition as well on the ISBN, which is good. But this is actually a union of all of these. So I can just shift click all of these, bring it out, and then drag it up until I see that union. I can drop that to make that a union. And now I have those union. And by doing that, it automatically created a physical layer. So you can see that it's a physical layer because I have this little icon here. So if you see that, or if you see the Venn diagram in there, that means that it is a, there's a physical layer within that. All right, now let's talk about something else. Now my model is built. Everything is out. I'm going to bring this down so you can see it all. Now, I can start clicking on some of these tables, and what you're going to notice is the only thing that's building here are, the only thing that I'm seeing are the columns and rows from that table. Remember, when we join, it just adds columns to the end, right? And adds rows for duplication if that happens. But with relationships, you just get to see that. You just get to see the tables in your, you just get to see the rows and columns in that table that you clicked on. And even when you click on in this one, you're only going to see that as well. So now that my model's built, we're ready to start creating some views. Now, again, we have different data sources here. Here are all of my different data sources. I'm just going to close these up real quick so that we can look at something. So the first thing you're probably going to notice is there's a field missing that we're used to. Number of records is gone. I'll pause for effect. The number of records field is gone. It does not exist. Why does it not exist? Well, because we haven't joined anything together. We haven't joined these tables together. Therefore, it can't calculate the number of records for my entire data model. Everything is being separate now, which means you have number of records for each table. So as you break out here, you have the table name and then count. That is the exact same thing as number of records, but is only for that table. So just keep in mind that that is a bit, I know that's going to be really uncomfortable for a lot of people to not know the total size of your data model. But when you really think about it, do you really need it? If you do need it, I did create it. I did create an old, a joined data model of all of these tables, joined just like, instead of using relationships, I did joins, and the total number of records is 1.05 billion records. So you can imagine the amount of processing and the amount of level of detail calculations that I would need to do to kind of deduplicate a lot of this data. So, but like I said, it's there. All right, so let's just start. We're just going to take this really simply, and we're going to show you some of the really interesting things that you can do with relationships now. So what I want to do is I want to show the number of books by author for all authors. So number of books is my measure. I bring count of books to columns, and I'll add my text. Oh, the other thing I want to do real quick is add a data source filter so that we're limit this data just a little bit, just so our worksheets look nice when I build this, to only look at the United States authors. There we go. All right, so we have 10 books. I want to do it by author. So I'm going to go to my author. Now, I'm going to bring, I need to create another calculated field. This is going to be author name. It's just first name plus space plus last name. Just like that. Okay. I'll sort this. Now, so in relationships, in this new era, if all of your dimensions only come from one table, all of your dimensions will show up, regardless of which measure you bring in. Right? So you can see that Wendell and Bravrig only have, they don't have any books from our book table, but they are in the author table as a dimension. So that's why they're showing up. But what if we bring out another measure where we don't have a matching value in it? Let's take a look at that. So so now we're going to look at the number of books and the number of checkouts by authors for all authors. So author name, I start this just as I did, book. I'm going to put on that. I'm going to sort this. Now I'm going to go to my checkouts table, and I'm just going to bring out a number of checkouts. I'm going to drag that up there. And now when I sort this, Tableau has 3 nulls because checkouts is only for books, right? It's not at the author level, it's at the book level. So Tableau doesn't have any matching values for my for these 2 folks who don't have any books. But luckily we can get around that if we double click this calculation and we just Z in out this, right? So if we just do Z in to 0 out our nulls, now we have that, right? So that's how we can, they're always there. You can get them. All right. Let's look at now, so that was 1 dimension, 2 measures, how we can get around that. Now let's look at 2 dimensions and 1 measure. So we'll look at authors with awards. So we've got author name. Now watch what happens when I drag out award name. So we've got 9 records here. Award name. You saw the number of records drop, right? We went from 9 to 4, right? So what happened? Well, Tableau essentially said, I think you just want to see matching records, right? So that's what we did. And what you can see is that basically what happened is, if you were to look at the background SQL, Tableau just did an inner join between those 2 dimensions, right? So now what we can do is, if we bring out number of books, if we go back to our book table, I'll collapse that, bring that here, book count. If I bring this out, now we have more authors because we're bringing in our book, right? So here we can just alias this so we know what we're talking about. and we'll call no award. Right? So you can see what happened here. So we have, so basically Tableau just did an inner join here, but by bringing in the books, it just changed the join type. It changed the underlying SQL. But that's still not quite what I want. So now I have for authors, but what about any author with books, right? So we'll do the same thing. We'll do author name, award name. We're going to build this up just like we would. Let's see. We've got, and then we'll do the number of books. Just like that, no award, but I know that there's still some out there. I know that there are some books out there that that don't have that. So what we're going to do is we're going to change the level of detail again. And we're going to change this to do a left join on author. And I'm going to do that by taking a measure and dropping that on detail, and watch what happens. Now I've got those two authors in my view because I've changed the level of detail into bringing out all of our authors. And again, we can sort this so you can see they're down at the end. Right? So again, as you build things, you're going to dynamically change the SQL, which is, again, pretty different than what we would have done. All right, let's keep going here. I think that's, yeah. All right, so the next thing we're going to look at is by, if we do, let's see, just a second here. Let's do by genre. So we can bring out our genre. Right there, we'll bring out books. We'll bring out the count of books. And if we wanted to, what if we wanted to, oh, let's see here. Let me think about, lost my train of thought, and I apologize. And then we'll do the number, and then we'll just say, how do we isolate the fiction? We can just write a calculation, right? That says fiction books. And we can do, this will say, this is just if genre equals fiction, then 1, else 0. And now when I bring that up here, thankfully, we did this right. So it's only counting those. And what if we want to get the number of, show the number of books sold? So we'll go down here to our sales, and then we'll just bring out our sales. There, and what's going to happen is we're going to see the number of sales by fiction or by genre, right? But we know that that's not, but what if we want to know the number of sales but for fiction books? So if we go to our fiction books, instead of else 0, couldn't we just do, then just return this guy? And then, but that won't work because we have to aggregate our genre. So what we can do here is we do our count if we do that, see, Tableau is not going to like this either because it has to have, by our table name, we have to have that in there. So another way that we can do that, get around this, and this is kind of a trick to kind of trick, we're again changing the level of detail within the calculation. So we're just going to do, we're actually going to go back to else one, then one, else zero. And we're actually just going to AND this with a non-null true statement. So what we're going to do is we're going to look for this. So our ISBN from our sales, and we're going to do this at the row level. So this will always be true, right? And now when we do this, you'll see that this changed, right? So immediately we were able to, within our calculation, we were able to change the level of detail. So again, very interesting stuff. And this is, again, if you've just come to Tableau, this is going to be a very interesting, interesting way of doing data sources and data models. But if you're old like me, this is kind of this is going to take a little bit of understanding. It's going to take a little bit of training to retrain our brains to think in terms of relationships and data models, as opposed to just joining everything together. Like I said, from what I've used in production, it really does just work. I was doing I had a project where basically I had a fact table, and then I was joining that to a date table. And so I was getting duplicate counts on my fact table for each date in my rows. So I had to do a calculation to aggregate that count down to a minimum, and then sum that minimum so that we didn't have any duplication in there. And then halfway through, we upgraded Tableau to introduce data models, and I just created the relationship, and it just worked. I didn't have to do any pre-processing of the data or any aggregations. It was just there. So really cool stuff. You know, there's basically what we're getting to, what we're getting closer to is the ability to relate two fact tables together, which if you've done any data modeling before, you know that there are certain instances where you need to do that, and Tableau makes that extremely difficult and almost impossible to do without a lot of heavy lifting on Tableau's part. So, but with relationships, we're getting closer to being able to do that, which is pretty exciting. So, again, this is just the introduction. This is just the tip of the iceberg. Definitely recommend go play with this. They've got Tableau's got some great help files and blog posts about how to learn more about relationships, and how you can do some really cool stuff with filtering, and similar to the stuff that I showed here at this last one, by changing the level of detail within the calculation, you can do some similar trickery along those lines. So really cool stuff, and happy to take any questions if there are any. Oh, lots of them, 5. All right, here we go. I'll try. All right, let's see. Yes, so good. First one is good here. The first major roadblock we ran into is data blending cannot be used with data models created with relationships. Data blending can only be used with the older. Yeah, so that's great. So think about this. So what we know about data blends, a blend is basically a join after aggregation, right? Whereas a relationship is going to do that at before the aggregation. So all of the things that you used to blend, you can now just add to your data model and relate if you have that ability, which is nice. If you're trying to blend two different Tableau data sources together. Unfortunately, we don't yet have the ability to manipulate multiple published Tableau data sources yet, but if you can create that as a table, you can do that. Again, another thing with blending, you probably ran into blending that trick, or not that trick, that awful pain with blending of a non-supported aggregation. That goes away with relationships because, again, you're doing the joins after you're doing your aggregation and filtering. So you're able to do basically a blend, if you will. You'll be able to do that and do a count distinct if you can set up your data model to use relationships as opposed to blending. Okay, so I know it says that everything is backwards compatible. So Katie says, I've been afraid to even download 2020.3 due to the new data models. I know everything says it should be backwards compatible, but have you tackled the switch in regard? Yes. So if you have all of your workbooks, if you haven't upgraded yet, when you open them, they will automatically be defaulted to the joins, and that's good or bad. I'll let you take your I'll leave that up for your opinion. But if you want to recreate an old data source into a data model, you have to recreate it from scratch. There is no easy button to just say take all those joins and make them relationships, unfortunately, which is what I had to do on my production project. But yes, you can, again, you can still use the joins. You can still use all of that stuff as you would. It's not going to change anything. It will still, like you said, it's still going to be backwards compatible. The joins will still be there. Everything stays intact. Nothing, we haven't experienced any breaking in those, so you don't have to worry about that. Everything will work. But the default new way to create data sources will be those relationships, unless you go into the physical layer. Let's see. Has anyone that is using the new relationships modeling option noticed any performance increase or decrease when pointing to an Excel-based data source? I don't. I have not experienced anything with any real benchmarks, but I can tell you the more level of detail calculations that you're able to remove is certainly going to increase performance and make that performance better. So I have only experienced positive performance changes regardless of data source. So definitely it's something to you definitely want to do some testing. That's something I want to make sure. You definitely need to do some testing in your environment. Open up your workbook in your legacy version, open it up in the new version, create your new data model and see how quickly you can recreate, how easy it is, everything it is, and then you can do some benchmark testing that way. And then, is there a limit to the number of tables that you can or should add to a data model without impacting performance? I think, again, Brian, I think this goes back to because everything is created everything is created on the worksheet. Tableau is only going to query the fields that need to be queried from the tables that are used in building that worksheet. Now, some of the things that I've thought about in the back of my head that I haven't really had time to really think about more is, what does that mean for interactivity, right? What does that mean for actions? If you've got your, if you have two worksheets and they're both multi-dimensional separate worksheets, and you want to have interactivity, what is going to be the impact of that? Because you haven't really related those together. So that part I'm curious about. I'm not worried about it, but I am cautiously curious about that kind of performance. But as soon as if I learn anything along the way, you know that I'll be willing to put out a blog post on my blog, or maybe I'll have another presentation as we kind of adopt this. We are not using this currently at Cerner, just because we've got some other stuff that we've got to figure out from a deployment environment phase. So we're working on that. Should be coming in the next couple of quarters, but let's see. And then the only other question I saw come in, do we have the ability to create relationships in Tableau Prep? No. Tableau Prep is single table instance only. Now, will that change? Maybe, probably. I'm not really sure. I haven't really seen anything on the roadmap. I can't imagine that. I'm sure that they're thinking about it. I think they'll have to probably, I think it would be really cool to, like, create out of Tableau Prep a universe, if you will. If you're familiar with, SAP Business Objects, you can kind of do all that massaging, cleaning, and then spitting out. Here are 5 tables that have been cleaned and scrubbed and shaped the way that I want them, and here's how I want them to be related. I think that could be a really interesting thing, and I'm sure it's something they're thinking about, but more to come on that. So, all right, I think that wraps up mine. Yeah. So we'll kind of go back here to that. Okay, so thank you so much, Jay or Aaron. Any final parting words?
No, I'll just kind of add on. Sean, you were one of the first people who got me less worried about relationships, because I remember the first time, I use number of records all the time, and I've always really encouraged people to understand their joins. Why are we using a left join? Why are we using an inner join? How does that change what data we get back, or what data we don't see? More importantly, what data gets kicked out? And I will say that you both put me at ease initially when we very first talked about this several months ago. And then I ended up with a project that the client had exactly what we wanted for 2 different data sources, completely different level of detail, and it worked beautifully. And so what I would say to folks is don't completely avoid upgrading out of fear. I did that for several months. I don't have time to learn this. You can have more than 2 instances of a Tableau desktop version on your machine. So go grab the new one. And I love that you have this data set to share that folks can kind of play with it. So that would be my only sort of personal anecdote of, yes, it feels a little funny, but man, once you see it working and all the level of detail calcs that suddenly you don't have to build, it speeds things up. It's pretty exciting.
Yeah, it is. Jay, any final words? No? Cool. Awesome. All right. Well, go Chiefs. Big game Sunday. Hopefully we can stick it to Tom Brady and get payback for a couple of years ago. So we will hopefully do that. Thank you everyone for joining, and go forth and viz.